We're going to look at the inverse normal distribution, which lets you go back and find values of your normal distribution. So what values you want up to. Alright, so if x is a normally distributed random variable, find m such that you have the probability from x less than or equal to m equals to 0.85. Now, because we're doing it where we're getting it from the negative side, all the way up to the negative side, yeah. The smaller side up to up to a point where it's equal to 0.85. When we're putting it in the normal distribution, so we want inverse, we need to set the tail end to be either on the left or the right or in the center. Now, if it says tail end to the left, then what it would do is, I can't draw it on the screen, it lets me, good. So we want the left side, so that goes up, and then it will stop at a certain point, where this whole area underneath will be equal to 0.85. Now, because of that, we need to set the tail end to the left. Our probability is 0.85. Our standard deviation is the one with the squared underneath the squared, so it's 1.5. And then our mean is 15.2. So that gives us 16. Oops. So then m is equal to 16.7547. All right. So we want n, given that the probability of x greater than n is equal to 0.37. So this time, we want to do the reverse. We want it so that it goes from left side. Let's see how the tail end is this end, and it's on the right. This time we want it to equal 0.37. So, do the inverse normal again. We want the tail end to be the right side this time, and probability to be 0.37, sigma to be 2.75, and then our mean to be 22. So then we get this was n, wasn't it? N to be equal to 22.9126. Alright, so part C is a little bit tricky. See how you have 37.6 minus p and 37.6 plus p. We want the middle to be equal to 0.65. However, if you have a look, because the middle is equal to 0.65, you have this section and this section, which is the other part of your area. And because normal distributions are symmetrical, and this is from the mean right here, which is 37.6, the other two areas must be equal to the rest, which is then 1 minus 0.65, which then gives us 0.35. And then it must be split in half, so we have 0.175. Now, because of that, we just simply have to find one of the sides, and then we can find p. So, interactive. Find the inverse again. You can either pick the left or right tail. I'm going to pick the left. The probability is 0.175. And then our sigma, our standard deviation is 12, and then our mean is 37.6. which then gives us 26.3849. Now remember, this is 37.6 minus p, so you can either use solve or whatever means you want. 37.6 minus p equals 26.3849, and then just simply just p. What did I do wrong? Whoops, it's a dot. There we go. And so P is going to be 11.2151. We can also use the cows to help us find mean or standard deviation. So sometimes you have to just put it onto a standard normal distribution, and then once you've used that, you can then translate it back to find different things. So whoops, you have to press A. For the normally distributed variable x, the 0.15 quartile is 1.9227 and the mean is 2.7. So if you don't get what the quartile is, as you go up from the left side, you want this little area thing, or if you like 0.15, it's probably 0.5. Now, the quartile is 1.9227, and so what we can do is find the z value for when this occurs. So to do that, interactive distribution. Now, because we want the z value, what we need to do is we need to leave these two so that we have our standard deviation being 1 and our mean being 0. Once you've done that, you'll get that the z value is equal to negative 1.036. And because we have that, z is equal to x minus the mean over sigma. We have negative 1.036 equals to 1.9327 minus the mean, which is 2.7, over sigma. So then sigma 1.9227 minus 2.7 over negative 1.036. So then we can find sigma, which is 1.9227 minus 2.7 divided by negative 1.036. Which is 0.753. Alright, we can do some more things. B. X is a normally distributed variable so that the 63rd percentile is 15.896 and the standard deviation is 2.7. So up to some certain point, just 15.896, and this one was 1.927. We have 0.63. So same thing, we want it to equal 0.63. So our standard score will then be equal to 0.3319. So, sorry, does that all the time. 0.3319 is equal to our x value minus the mean over our sigma, which is 2.7. So rearranging this, we get mu equals to 15.896 minus 2.7 times 0.3319. So then we get 15.896 minus 2.7 times 0.3319, which then gives us 14.9998. Or 9999 in this case.